All right, welcome everyone to yet another, a session, live training session for our Devops Hackathon. And I would like to welcome. We have a lot of people joining in today. So we have, I see Abhishek, Atul, Gautam, Harish Rao, Harish K, Lokesh, Nitin, Ranjit, Rupal, Sanjay, Santosh, Utkarsha. So welcome everyone to this live session. A lot of you are already part of our, the School of DevOps community. Some of you are joining as part of the live session that I sort of posted on different social media. And we have a lot more people joining in through the live streams as well on Facebook and YouTube and LinkedIn today. So I would like to welcome everyone, and let's get started with today's agenda. So we are talking about Git, or a mission called as Gitofy, and that is part of our DevOps ongoing DevOps hackathon. Those of you who are joining in for the first time, we run this DevOps hackathon quarterly, and this is part of our membership programs, including the silver membership, which is the DevOps associate program. We calling it as a DevOps associate mini degree now. And what do we do as part of this hackathon is we are building an end-to-end DevOps project with multiple missions. There are about 11 missions with multiple projects, and each of the mission touches one aspect of DevOps, starting with designing a DevOps solution with the microservices and discussing the use case. We started then decorating. So I've given these interesting one-word names, which are verbs. So we are doing something. It defines an action or denotes an action. So decorate is when we are launching and deploying container-based application. Containerize is when we are building container images. Gitofy is what we are taking up today, where we are talking about Git, GitHub, Git-based workflows, and implementing trunk-based development, which is what we're going to get started with in this session. Next session, we will talk about building a continuous integration pipeline. So we are going to pipeline it. Then we're going to Ansible-ize, where we will deploy an application with Ansible and talk about configuration management. Then we're going to cloudify stuff using AWS as a cloud, where we're building a two-tier application with high availability, scalability, and fault tolerance, resilience, and so on. We're going to talk about all of that. We're going to terraformalize that, meaning we will automate or write automation to provision that cloud infrastructure that has been built in the previous mission using Terraform, which is one of the most interesting popular tools today. We will then Kubernetify, meaning we'll start deploying that application with Kubernetes, talk about how do we do that at scale. And we would then automate that deployment with GitOps. That is where Argo CD comes in. So we'll GitOpsidize it, and we will then, monitorize it. Monitorize is where we'll set up a Prometheus and Grafana-based monitoring system. And this is for one large microservices application stack. And I have also, so updates for our members include, we're gonna bring in a lot of interesting stuff for you. And one of that includes, I have been working on, let's say, solidifying this roadmap and the progress map. So you will see, if you're logged into this portal, this is a membership portal, by the way. Once you become a member, you get access to this. And here you see, I have simplified stuff, and then I have made it very solid today. Let's say if you go to the roadmaps, you see DevOps Hackathon. You can track your progress through this DevOps Hackathon from here. And each of these milestones, which includes Designify, Dockerate, Containerize, Gitofy, pipeline it, right? So you will see the steps required to complete that milestone. And I'm gonna start adding the steps as well as the content related to that as we progress through this week by week. And you can see that already we have, for the Gitofy, mission for this week, I have already added 7 steps, which include your learning steps. There are a couple of projects there. And as you complete each of this, it will show up in your progress map, and you will also be awarded. So the next thing that we have also done is added, let's say, the points-based system. So we already had the learning minutes for every lesson that you learn. And now we have added the project time and project minutes as well. And this will work towards your certification and what we call as a mini degree program. And this is just like going to a university where you have credit hours. So ultimately, this will get converted into credit hours, project hours, and so on. And that will account for your, let's say, your certification as well. And then you would be allocated badges based on that. So I'll show you the badges. So we have Badger integration with badger.io. So this is like a open verifiable badges. So if you have taken CK certification and all that recently, you know the badge that you've received is from a similar system, open credential system. And for example, if you complete the containerization mission, you would be awarded a badge, and ultimately you will be awarded certification. So what would matter here most is the certification that we would award. That includes the DevOps Associate program and the certification related to that. And there's a very clear criteria. So you can put it on your LinkedIn and social media, and anyone can verify your specific certification, who that was assigned to, for what reason, and what you have completed, what kind of a work you have completed, etc. So all of that is gonna be interesting. So we're trying to gamify and give you visibility into your progress as well. And this progress map is getting better every week as we proceed from here. So this is something I wanted to share with all of the members. And this is the mission we are on, that is Gitofy. And let me talk about what you have to complete to what are the steps you have to take to complete this mission. So you have to learn. So if you go to this mission, you will see that you have to learn the content, which is in the form of video courses. And this is where I'm going to teach you the concepts today. And it's a similar concepts you would learn through the video lessons as well. And after that, you would complete a couple of projects. I'm hoping you're all able to see my screen as well. I believe so. Okay, just doing a quick check-in there.
Yes, we can.
All right, perfect. And as you can see, you're going to learn about how do you get started with Git, GitHub, branching and merging, pull request, trunk-based development. There is enforcing like branch policies. There's a topic on tagging with Git. That's how you release your code and create your releases. Semantic versioning, which is related to that. And this content has been refreshed. So if you have taken the previous iterations of hackathon, there is a new content for you in terms of definitely for semantic versioning, also a little bit on trunk-based development model, which continues on the previous one. And there are a couple of projects where you are going to start working with different branches and also streamline the development with or set up the workflow for our application. This is the mogambo.org's microservices application stack, and you're going to set up the trunk-based development for that. That defines the branching model. We'll talk about that today. So what are the things that we're going to talk about today here is we'll get started with the basics of container operations. So that's what we'll get started with, like basics of like Git workflow. We will also talk about, let's say, branching and merging. Basics of Git workflow is where how you fork, clone, start committing your code, etc. The three trees of Git, that's what I would tell you about. Then we will also talk about, let's say, the branching and merging, which defines the foundation for your workflow, which is also where pull requests based workflow come in. We will talk about the branching models. Branching models is where we're going to elaborate on the trunk-based development model. Any other branching models that you have used or are aware of, you can put it in the chat if you are on the Zoom channel. All right. So this is what we're going to talk about. And I will get started with very basics of how you get started with the Git-based workflow right from there, right? And we will, let's say, fork and monolith is not kind of a branching model. If you talk about branching models explicitly, when we say branching model, it is more about Git flow, GitHub Flow. If you just search for Git branching models, that's what you will get. And there's a very popular diagram I'll show you. Git branching model is where you will typically see this diagram from NV, uh, which is this image. This image is what you will typically see, right? These are the branching. This is example of a branching model. This is an example of a branching model that we followed in the previous organization that I worked for was something very similar to this, right? It's quite complex, but what we will create is going to be a very simplistic version of a branching model that we are going to use. But this is one example of a branching model where you have develop branch, there's a master branch or a main line or a trunk, release branches, because the reason why branching models are important to know, because this defines your workflow, how your work progresses, how fast it's going to go, and how you develop your features, bring the changes into the main line, how it gets released when a lot of those things depend on the branching model. And that's where Git flow, GitHub flow, trunk-based development, those are the branching models. And master branch, node branch, feature branch, develop branch, these are the branches. And branching model defines how many branches, what happens with each branches, when do you submit the code, and when you create a new branch. So all of that is defined by the branching model. That's where branching models come in. So let's get started with today's agenda. I don't have, unfortunately, my whiteboard with me, so I'm going to try and use directly from my computer. Generally, I use the iPad and explain, but I don't have that explainer with me today. So I'll try to use something which I have quick access to, but not going to be the ideal situation for today, especially for today, because I really wanted to explain everything with, let's say, the slides and stuff. But that's fine. So you can always watch the videos. And we have, let's say, those videos with, let's say, the explainers and how it progresses when you make changes and commits and so on. So how do you get started with Git and GitHub? Let's get started with that. And I'm going to take an example, a sample application, sample repository, sample code repository. And let's assume that we are DevOps, professionals who have been assigned with the work of setting up the trunk-based development, and who may also be responsible for writing and committing the code related to deployment. And let's say this is a Kubernetes deployment for this application. So the application code is there. We're going to add some deployment code. And through that, we will also learn about how do you get started with Git, committing your changes, bringing in your code, working with the branches, setting up the branching models and enforcing those. What are the branching models? So that's how I'm going to explain this process here. This is the repository that we get started with. It's called as InstaVote application, and this has a few microservices: vote, result, worker. This was originally created by Docker as a sample app, and it's a polyglot microservices application. Polyglot as in there is a Python application, there is a Java application, there is a Node.js application, and so on and so forth. Now, how do we get started is I need to clone this code. So if I have access to the repository and organization, I can clone it. Otherwise, what I have to do is create a fork out of it. Now, what is a fork? Fork is basically a copy of the entire repository, but under my account. So instead of me getting an access to this account called as LFS269, this organization, let's say I don't have access to that. So what I do is create a fork of it. So this is called as an upstream. So what I'm cloning is called as an upstream or original repository. And I create my own fork of it. This is mine, right? And this is a fork of it. And then I would clone it on my workstation. This is what I'm going to get started with. And this is also, if you want to contribute to an open source project, let's say you want to contribute to the Kubernetes project, you can do so using the same method. So if you want to contribute to Kubernetes project, what you have to do is go and check where is the Kubernetes original repository, right? Typically on GitHub. It is on GitHub, of course. So maybe if I search for Kubernetes, I may find it. It is there. And if I want to contribute to the actual Kubernetes project, this is how I work with that. So I create a fork of it. So there are 37,000 forks today, right? So I can create my own fork, and then I can make some changes to it. And if I want to submit those changes, I create something called the pull request. We'll come to the pull request later, but that's how this workflow happens. So typically with these kind of projects, a lot of times you will work on that, or you may have access to the repository directly, in which case you don't have to fork. This is not needed, but you will directly clone and push to that original repository as well, depending on how this has been set up. But I'm creating a fork of this repository. This is the original LFS269. I am logged into my account. The account name is Devops Demo, and this is my account. And I will begin modifying the code by first creating a copy of this repository. So how do I do that? Create a fork of it. So just say fork. It opens up a configuration like this, and I choose my my account and say create a fork. That's all. That's all it takes to create a copy of the entire code repository with all the branches if needed, right? So right now probably it just has one branch, and right now nowadays it copies only one branch, but earlier it used to copy the entire set of branches. If it had 10 branches, 15 branches, it would create a copy of that. So now this becomes my own copy of it. You can also see when I look at this repository, it says forked from XYZ. This is the original. This is called an upstream. I can submit the changes to this as well later if I want to. This is upstream. This is my own repository called as InstaWood. And this is Devops Demo InstaWood. So I get my own copy of it. Now I will clone it. Clone it where? Wherever I have Git installed. So this is my workstation where I'm logged in as me. I have Git installed here. If I just run Git command, I see it. And this is where I clone it. When I clone it, gives me a copy of this entire repository. The way Git works is every clone is kind of a backup of it. It's a distributed kind of a revision control system. And every clone can by itself be a self-sufficient a copy of the entire code base also, right? So that's how Git works. And I switch to this directory where I have cloned it. I can then start adding or doing the basic revision control. When you say revision control, this is mainly useful to keep track of the history of changes to a code. There's a particular file that you've written and added, and if there have been multiple changes by different people, how do you collaborate? How do you coordinate those changes? How do you look at the history of the changes? That's where revision controlling comes in. So there are multiple revisions kept for each file, and there's a history of revisions and all that. Now, how do I start with Git? Is I'll have to first configure Git so that when I commit the changes and all that, it knows about who am I, which user I am. So I have to add some configuration first. So if I look at git config, right now it does not have any user related configuration, and so I will start adding the configuration. By the way, whatever I'm going to demonstrate here, there is a lab guide available for that as part of the mission itself. So when you go back and start learning, you would basically download that lab guide and complete these steps as well. So if you have access to this portal, that is. So I'll just show you where that lab guide is. This is the PDF version of it. And whatever I'm going to do now, so let's say work with Git, everything in details with the screenshots. How do I clone? What do I do? How do I configure? And step by step, everything is available as part of this lab guide, right? That is for the lab part. And then there are projects where you will take some action. You'll be given the problem statement, and you have to complete a couple of tasks there after going through this learning phase. So first you learn the concepts, then you do the labs, then you complete the project. That's how we master that technology. Okay, so what am I doing here? I've cloned it. I want to start configuring the Git. here first. How do I do that is where I will start looking at, I've shown you the configuration, but how do I add there are three different types of configurations here really, right? So there is, I can also list the local, global, and system level configuration. Local is constrained to my workspace and that particular repository or a directory. So if I create a local configuration, I'm just trying to search for my whiteboard, which is lost somewhere. So local is the most specific to one repository, like one directory, let's assume. That's local. Then comes the global. Global is for a particular user. And then system-wide configuration is system. So local, global, and system. System is for the entire system for all the users, basically. That is the difference between local, global, and system. So what I'm going to do is create a user-specific configuration. All the repositories that are owned by this user will have that configuration. So I'm going to add the configuration, which is the global config. And generally, you add a config like this. So git config -- global username and whatever your names. I'm just going to say demo user. So all the commits would appear like from this user, basically. I can add my name as well. So I can just say, okay, this is who is working on it. So all the commits would originate with my name now. This would depend on the account. So my account on this Firefox, this one, the one I'm demonstrating here, this account has been configured with a particular email address and whatnot. That email address I'm going to provide here. So the commits will be marked with this particular user. That's what this means, basically. And I can look at the configuration by listing. So if I do config list, you see the username and email. Where does this come from? Is it a local configuration? Let's find out. No. Is this a system configuration? Again, no, there's no system configuration. This is a global configuration. That's what I've configured, right? So this is part of the global configuration, meaning it will be for the user, specific to this user. Any repositories that this user configures will be with this user. Username as in Git username I'm talking about. Now, basics of revision controls operations is what I'm going to do. The objective here is to add some code, add some deployment code to it. Now, this is my repository, which is hosted on Git here. And locally, when I clone that code, I have three different places where I can add this code at, right? So these three things are called as three trees of Git, which is a unique and interesting concept related to Git. Now, who created Git, by the way? Do you know who created Git? You can put it in the chat. Very interesting question. Have you thought about it? Probably not. Yes, so Divya is absolutely right. So a lot of you may be surprised to know that Git is created by the same person who wrote the Linux kernel. The Linux operating system, the name came from the kernel. And the name of the kernel came from the person who created it, called as Linus Torvalds. And he's the one who created, Git as well. And he wrote this entire Git system in about 3 weeks or so. So it's like amazing work that was done at that time. And it's a revolutionary thing, because before that we used to use, so I remember using SVN, CVS, and those were the open source revision control system, which were complex and not meant for the open source projects either. And Git is much better and kind of a revolutionary work And that's the story behind Git. By the way, that's like some interesting factoid about it. Uh, Now there are three trees of Git. What do you mean by that is there is some place where I make changes. So when I make changes, it is going to my current path and the folder where everything is checked out. So when you say checked out, what does that mean is these files which are checked out from the repository, meaning when they are committed, they are stored in a compressed version. There's a compressed file and the compressed commit actually, which goes into and gets stored there. And then when I check out, it gives me a uncompressed version of the file which I can work with. And that's what you see here. This is my working directory. This is my working area. And this is my what is called as a working directory as well. This is where I make changes. So what I would do is I add some code. What code? I'm going to add some Kubernetes deployment code here. I'm just following the steps in the lab guide, basically, where I'm creating some directory. So I'm just adding a directory called as deploy. Underneath this same path, I'm creating a directory called as deploy. And then inside deploy, I will create a vote directory. So I can also use a recursive option or M option. I think it's minus M option. I'm forgetting the option. Parent directory. Yeah, sorry. Parent directory as in it will create this and this both. So it's basically deploy and vote. I created in one go. Yeah, this is what happens when you use a lot of abstracted tools and not, used to run the Linux commands all the time. So today I would create this structure with Ansible, right? So that's the way things got abstracted at some point of time. Anyway, so I'm in this deploy directory, in this vote directory. This is where I'll add a couple of deployment files. I already have the copies of that. So I'm just downloading it basically using these commands. Just adding a couple of files where I added or downloaded. So we're not writing this and all that. We are focusing purely on the revision control system. All of this is given in the lab guide. How do you create these files where, or you can add any files for that matter. That's fine. So I'm just adding two files. So these files got added where? In my working area. Now I want to add this to the Git and it should reflect onto my repository at some point of time as well. Before it goes into this repository, it doesn't get, when I say push and commit, it doesn't immediately, when I commit, it doesn't go here directly. It gets added to a staging area in between. So there are three things which are available on my system right now. One is the working tree or a working area, working directory. There is a staging area, the second place, and then where it gets staged for the commit. Why it gets staged for the commit? Because I may be making multiple changes and I add a file and then I make add another file later, add another file later. So I want to commit three files together in one single commit. I can do so because I have this staging area. I get staged. Each of this file got staged, and only when I commit. So when I say git add, it goes here. When I say git commit, only then it goes into the commit history. And then when I say git push, then it goes to the remote, which is my GitHub repository that you see here. So even before it goes to the remote, I have these things locally available: the commit history, staging snapshot or staging area, as I call it, and the working directory. This is also called as an index. A lot of time this is called as an index as well, or a head. This is an index, this is the head. Basically, this is called as this is where your head is pointing. Head is basically the tip of the current commit or current branch and the commit that you are at, right? That's the pointer. It's called as a head. So where I'm adding this is currently in the working directory. It is not being tracked by Git yet. How do I check this? This is where I'm showing this command. So git status shows me that there is nothing in my staging area, nothing there at all, right? So it doesn't show anything. Now I'll add these files, git add, one file at a time, or I can just say git add star, which would take all the changes, all the files that I have, and start adding it to the staging area. Earlier, it was just in my working directory. Now it is in the staging area. Now it is gone here. I can bring it back also from the staging and remove it from that before committing, or add more files to it also later. And then only when I say git commit, and I can say git commit and then add like adding initial code, something like this. This is the time it got into the, it's gone from the staging area. Where is it gone? It went into my commit history. How do I check the commit history? Is git log. So git status, git log. Remember these commands. Git log tells me this is the commit history. This is the commit ID. There's a unique ID for it. And this is where it shows me where my head is pointing to. Head is like the current pointer to the current, index and the code that I'm working on. This is pointing to the main branch right now. That's the one I have checked out here. And this is where my changes are gone. So my changes have been committed. This is the time I'll say it's been committed. Does it mean at this time it shows up here? No, it doesn't. It only shows these two commits, the initial import. Okay, I should have said adding deployment code here. That's fine, but that's my third commit. It doesn't show up here. Why? Because it's still available in my local index. I have to push it using something like this, git push origin. Now I'm talking about a remote. So we're talking about remotes. So when I cloned this code, what did I do? I cloned it from the later. So this was my upstream. I created a fork of it. This is what I cloned. This is my current repository on my workstation, right? This is where I cloned it, right? And whatever I've cloned it with all the branches. So when I publish the changes, when I say push origin, origin is this part. Origin is this basically. This is where I've created my fork. This is on GitHub. So this is on GitHub. And this is where I cloned it from. And when I push, I'm pushing it to what? To a remote. Remote is remote to me. It's not local, right? There's a local and this remote. I can also add this as a remote. This will be added as a different remote. I can check all these remotes by looking at git remote show, and there is only origin because that's the default. Origin tells me what is my origin. This is my origin. GitHub, this particular user, this particular repo. I can add multiple remotes also. So I can also say git remote add. This is like the additional thing that I'm showing you now. And I can take this repository and add this as a remote. And I'll say this is my upstream. And now I have two different remotes. I can also talk to upstream. I can push the changes to that if I want to, or I can push changes to my origin. So I can do both. So Git, that's why it is called as a distributed revision control system. You can talk to any of the copy created by anyone, really. That's how cool it is. So I'm pushing it to origin. So when I say git push, that's why we say git push origin. That's what I'm pushing to. And a branch. This is where I have to call a branch. That is main. Now here I cannot use a password. Even if I call for a password, I have to create a token and use it. This is a change from earlier. So if you see my videos, I may have a password there, but now you have to create a token. How do I create a token? Is I go to my account, go to the setting. It is part of the lab guide, but I'm just walking you through this. Go to the developer settings and I create a access token. I'll use a classic token here and generate a token. This is where I have to provide my password and then validity of that. Let's say 7 days. I'll call it as 0. And I'll provide repository. Right now, I'm just providing all repository access. If you want to provide very particular repository and access to that, you can use fine-grained token instead. I'm using a classic token, which is a simpler version, which gives me access to all my repositories. And this is the token I have to use as my password. Only that would work, not your password. Actual password would not work. Okay, I'm just adding this token somewhere so that I know or I can access it, or I have a token here from earlier. You can use multiple tokens. That's the good part about tokens. If you lose tokens, you can deactivate those also. So let's say I've stored the token for later use, and I have committed and pushed the changes. So first I added to the staging area. From there, I committed to the index. From there, I've pushed to the origin. Origin is now this. And if I look at my repository here, I should see all these changes. If I look at my repository, Instavote, I should see the commit being added. Now I see 3 commits. Earlier there were 2. Now the changes are reflected on the remote side, which is my, origin. This is the typical workflow. If you make changes to it, let's say I have these existing files. So I showed you how to add the files. Now I'll show you how to make the changes as well. So I'll just add a change to one of the files. And I'll create a new file. This is a new file. And then I'll also change, that I'll show you a little later. I'm changing something a little later. So I'll show you that then. You can also use git diff, basically. That's what I wanted to show. So git diff, if there is a change to an existing file, for example, I have this already tracked by Git, and I go here and add something. Then it also shows me the changed file, the changes. This got added. That's what it tells me. Basically, that's a diff. So I can also check the changes. I can also look at the Git status. It says this has been modified. This has been untracked. So it is added to my working area. You know how this works now. And then when I say git add, it will go to the staging area. It will get staged when I say git add, and readme is here or here. No, it is being tracked. This is modified, this is tracked, but this is in the staging area. And when I commit, you can also do a -am will automatically also add everything anyways, right? That will automatically happen. And at this time, it is not here because it is gone into the commit history, which shows up in the log. So now I have the 4th commit, which says updated readme. And I see it in the log. So the head of my current index is pointing to the main branch in this commit, but my origin is this is still pointing to this commit. It tells me that actually origin head is also pointing to that the particular previous commit. And only when I, let's say, push the changes to origin is when it shows the origin is now updated with this. So if at this time, I should see the 4th commit as well. Okay, Nishant asks, was that a merge conflict where the file said modified? No, that is not a merge conflict. Merge conflict will show up as a merge conflict, and the conflict happens when there are multiple collaborators. Let's say you and I are working on the same file. I made changes to line number 2, you made changes to line number 4, or you made changes to line number 2 and 4. So there will be a conflict on line number 2 because I have made the changes. We committed at the same time, like say 1 hour ago. I made the changes and I pushed the changes a half an hour earlier. You have made the changes, line number 2 and 4, same line as I did, like one of the lines. So line number 2 will have a merge conflict when you try to push the changes. That is when the conflict happens. For that, you need at least 2 collaborators, and you should be modifying the same line of the code. That's when the conflict happens. Okay, this is what we're just adding to the the history of changes we're tracking now. And let's look at we talked about the basics Git operations like add, commit, diff, push. These are kind of the ones you use typically very often to make changes and so on. And we also talked about the remote concept of remote, like origin is my remote. I can have another remote called as upstream. I can connect to another someone else's copy or repository and connect to them as a different remote as well and collaborate also. So all of that is possible. Now let's talk about branching and how does that work with Git, right? And branches are typically very useful for creating different branches of development at different pace and different times and so on. And it maintains a history of that. So this is like my main branch. This is like the first branch I started with, called as a main line or a trunk also. And then for, let's say there are 10 different teams working on 5 different projects, and multiple features, all the code is going into the same repository. So you can actually branch out and create different branches for different features which are going into different projects and all that, maybe different features on the same project that you're working on. So you create different branches for that, and then ultimately you bring those changes into the main line because this is where you want to deploy from, etc. The reason why you're creating branches is for keeping that branch of development or track of development separate than the main line, so that you can add the code, you can experiment, you can break things if you want. But the main line, which is going to your typically your staging and your production and all that, that doesn't get affected. So, let's say you have 150 developers all working on different project, different features. You're not breaking the code in that stable main line. That's why it is called as a trunk or the main line. Trunk of a tree, that the main trunk of a tree, and then you branch out here and there, and then those changes can be merged into the main line of code at some point of time. That is called as a merging. So how does that work is what I'm going to quickly demonstrate to you, the concept of branching and merging. All right. So how do I create a branch is which branch I'm on. Let's have a look. You can also look at the branches here. There's only one branch called as main. That's what was copied. And that's the only branch I have available locally. I can check that by using git branch. There's only one branch, main. How do I create branches? You have a couple of options. You can create a branch like this, and then switch to that branch, meaning I've created the branch, but I'm still on the main branch. That's what I see, the asterisk. I can also look at the git log. The head is still pointing to the main. If I want to switch to the test branch, which is this, I have to use git checkout test here. I can create and switch by using this one command also, but otherwise I'll have to switch. So now it says switch to the branch called as test, and I can confirm and double confirm that my head of my current index and everything is pointing to the test branch. That's where I'm working on right now. Right, so that's the branch that I've created. Now let's add some commits to this branch. The main branch has 4 commits that you see here. I'm going to add one more commit, which will go to the feature branch, the test branch, basically. So this is where I will add something to the README. Okay. Just one line of code I've added, and Gitdef now shows me this is what I changed. Git status shows me this has been modified. Yeah. If I had added a file, it would have showed this file is added. And then this goes into the commit history. So git log shows me that. You see, it's been, has it gone into commit history yet? No, I was just doing a diff status, and that's it. It's not in the commit history either. Let's look at the status. I did, I think. Okay, so it is there. Sorry. This is where everything else is pointing to. My main branch. This is where the main branch is. If I switch to the main branch, I'm not going to see that change. This is where the magic happens. So I have the change. Now I don't have the change because the only thing that I did here is this is where my main branch is pointing to, right? That's why I didn't see that change. So if I switch it back to the test branch, git checkout. Now I again have the change, right? That's part of the staging, and all that index and all those things are hiding it and showing you when you switch between the branches, etc. And I have it as part of my commit history, which you see here, this update, right? And then I can push that, or I can merge it into the main if I want to, or I can push it to the to the upstream or origin as well. Let's say I want to bring the changes in. I've added a couple of features and I want to bring the changes into the main line of the code. So I'll add one more change maybe. So I'll go and update this file, delete a few things. From the code. I see it here. This is the second change or second commit. This time I'm not going to add. I will just say git commit. And at this time, you are going to see two commits. This is two commits ahead of the main branch actually. So how do I bring the changes into the main branch so that the main branch starts pointing to this? Is I merge the changes into the main. That's what I can do. If I want to merge the changes, how do I do that? Is I'll have to switch the branch first. To main. Yeah. And then I'll say git merge. What I'm merging test into the current branch I'm in, the main branch. And when I do this, you are going to see main is now pointing to, head is pointing to main, and main is here now. Main is also pointing to this locally. And at this time, if I say git push origin, test origin main, the main will have these changes. At this time, the main branch will have those two more commits. So now it's 6 commits, and those two commits are added here. Does it show test branch? No, because I've not pushed that yet, or I've not pushed that at all. I'm not pushing it. I'm just deleting that branch using git branch -d. So I've brought the changes into main, so I can delete the test branch from here. So that's what I did. I can also push the test branch or this branch to, let's say, the origin there as well. Now, let's extend on this concept of branching, merging, and to merge the changes, we will add a process. And that is where something called as pull request comes in. So this time what I'll do is I'll create a branch from here itself. I can do it from here and push it also, okay? I can create a branch from here. And when I say git push origin test branch, it will push to that branch. I'm creating a branch called as feature X, feature A, let's say. So I have a couple of branches here. And when I say git pull origin, it has started tracking this branch. I can make changes to it. Yeah. And then I can publish the changes to this feature branch here as well, right? So that's what I'm going to do. So main branch has 6 commits. I'm changing the code back. There are ways to undo changes also if you want. I'm just adding the same part of the previous code again. So this is like modifying a file. All right, that's what I have. I say git diff. You see the changes. Git status shows me the file modified, 2 files modified. Git commit. And I say git push origin, but to feature X branch, feature A branch. Oh, I did not check out to the branch. Sorry. So I should have done this first to track that. The changes went into my main branch actually. So I'll have to go back here. I'll do a reset. So this is this commit added to the main branch, right? I want to reset. I want to remove that commit. I can do that. It has not been pushed yet either. So this is easy. So git reset head -1. So it will point me back by 1 commit. So this is head -1. Yeah, it has unstaged those changes. It has removed it from the commit history. So there was one more commit after this. If you notice here, after this, there was one more commit. This commit is gone. I just removed it from the history. The files are still there, untracked. So this is what a soft reset is. If you remove these files or the changes, that is called as a hard reset. All the changes would be reset at that time. So what I'm doing now is git checkout feature A. Yeah, I still see the changes. So I commit it. Where does it go? It goes to the feature branch now, not the main. Okay, and then I push it to the feature branch. So origin feature A is what I'm pushing the changes to. And that publishes the changes to the feature branch. Yes, so you see main, there is a feature branch, and now it has one more commit. How do I bring these changes to the main and merge it from this place? The origin here is where we typically implement the feed pull request, and pull request is a request to merge. It can be between two different branches of my own repository. I can also raise a pull request against an upstream, like this is the upstream. I can raise a pull request against it as well. I've forked it, I've made the changes, and I say that, oh, please take these changes. I'm making this modification, which you might find useful as well. So you can also take them as well. And that's what you can raise a pull request against too. So how do I do that is, let's say I go to this branch where I have the changes in my repository, of course, and I can go to the pull request and create a pull request. Sometimes I see that this feature branch is ahead of this, and you go and create a pull request. Sometimes I see a pop-up here itself. That happens too. If I do not see it, I'll go here, say new pull request. And then this is an important step. This is where you decide who do you want to send the request to, right? From where is your branch? Let's say a feature branch of mine. And then I would say I want to raise the request against my own main branch, not someone else's, right? So not an upstream or anywhere else. So the moment I chose my own repository, it only shows the branches, feature and main. And you see that diff here, all the changes, create a pull request, and I can add the changes, right? So what are the changes I've made? Create a pull request here. And this is good because this is where you can discuss the changes. This is where you can add the code reviews. We will enforce the code reviews later. This is where you can wait for the status checks, like continuous integration checks. So only if the changes are tested and they look fine and they're not breaking the build and they're complying with the test policies, will you allow it to merge? And that is where you can enforce a lot of different policies. That's why pull requests are very useful. And you can discuss the changes actually. You can add comments, review the changes. And then when you're done with that, you want to merge the changes, instead of just saying git merge, you do it from here. So I'm confirming the merge. And then after that, I'm deleting my feature branch also. This is all happening on the origin side, meaning it's happening on GitHub on the remote side, right? I just have one branch and it does have the 7th commit, plus there's a merge has added one more commit, so that you have this part of a history that this was a branch it was merged from and at this point of time and so on. And I can bring those changes in here. I can, let's say, when I delete the branch from GitHub side, it does not delete it here. I have to delete it explicitly. And then this is not up to date, right? It is at this commit. And when I say git pull origin, it brings all the changes. Now, the changes and the commit has added, into one basically change of its own as well. That is what you see here. Any questions so far? If you have any questions, you can feel free to stop me anytime actually. Okay, so that's about pull requests, pull-based workflows, and so on. A pull request is actually a request to merge You make the changes and ask someone to merge those changes, take those changes and merge them into certain branch. A lot of times you have specific teams or managers like release managers who are handling all the merging to the main line and all that. And that is where a lot of things can be enforced. And that is what we want to enforce. Now, the next thing that we want to look at is that enforcement of certain branching policies. And this is where we talk about a trunk-based development model. There are many different branching models, and one of that is called as Git flow. This is the Git flow, actually, the one I showed you here. To explain what this means is basically, if you look at this particular branching model, which is a little complex, but your branching model defines how you do the development, how you release the product, which branch you release it out of. And in this case, the trunk or the mainline is typically developed. This is like the stable branch. And every feature branch, let's say you start with a sprint, the beginning of the sprint, you create the feature, or feature branches can be created anytime or at the beginning of that sprint. And then at the beginning of the sprint, you create maybe a release branch also. And all the features are gone into develop. From there, it goes to the release branch. Release branch is where you tag the releases from. So when you tag the release, basically you define that this is the version I want to release out, and create a package and artifact with and deploy it and all that. And that's where you'll add 1.0, 1.2, 1.3, etc. And then from there, this is your master branch in this case, and this is where you are publishing the changes from. This is where it is releasing it to the production, basically. All right, so Atul has a question about develop and master branch, like trunk, basically, which you cannot delete, right? So you don't delete the develop branch. You, in fact, protect those. You typically, that's what we're talking about now. Trunk-based development is where what we're going to do is we'll look at a very simplistic model. Forget about all this complexity, right? So we'll just say that we're going to use a trunk-based development model where everything ultimately gets checked into a trunk, like what we see as develop, or what is a mainline code that we have. So there is an entire site dedicated to trunk-based development, by the way. I have this linked into the lab guide. I've just shared the link with you as well. So there are a couple of variations of it. For smaller teams, let's say, everything is getting checked into master. This is like very basic thing that you can start with. And then you can just release the product out of the master branch itself, or maybe create a release branch here. And a scaled trunk-based development model typically is what is followed when we say trunk-based development model, where you have one main line of code that you don't delete, you protect that. In fact, you do not allow changes directly going into the trunk. You lock it down, you protect it, and the changes can be brought in only through the branches. And then you create short-lived branches typically. Like you want to create a feature, you create a branch, develop part of the feature, and then when you want to merge it, you merge and then delete that branch, so that you are bringing the changes frequently into the trunk. So the chances of adding conflicts, like merge conflicts and all that, are reduced if you are bringing the changes at a regular interval, and you're doing it in a safer way. So when you're working on that feature or that small part of the feature, one small feature, you are not breaking the build. The mainline is locked, and you allow changes only to go in when it is stable enough, right? So that's when you bring the changes in. So how do we enforce this? Whereas, let me illustrate this part. So a trunk-based development model maintains a mainline code. One main branch, one large main branch that never gets deleted. Let's say there's a release branch you may have, but the main branch is what the most important part here is. So this is the main branch. this never gets deleted. And what you do is you bring in the changes by adding feature branches. So this is one feature branch. There is another feature branch. Maybe you create a branch of the feature branch, right? And you're adding commits to the feature branches, maybe in parallel as well. And what you do is you bring the changes in. When you bring the changes in, the only way to bring the changes in is where you raise a pull request. And at this time, you seek input from continuous integration, whether this is all fine, the checks are going fine or not. You seek inputs or do the code reviews with your peers here, and the peers would look at your code. Only everything is okay. When everything is okay, you allow it to merge into the main line. You do the same for every single branch. And you can have another branch sitting on top of this, bringing the changes in here, and then you add more changes to this. And then when you try to merge, this is where the pull request and that workflow comes in at this point of time. And how do we set up this policies where this is locked and you're enforcing the changes only via pull request and branches, is where we implement something branch protection rule. But this is in a simplistic way, a trunk-based development where the trunk is stable, and at the end of the release, let's say end of the release, you cut the release to a release branch, you create a branch, and off that branch, you basically define or push these changes to the production, basically. And this is stable enough because you've tested everything on trunk, you've tested before bringing the changes in as well. And that is how you implement the trunk-based development model. How do you implement is very simple. Right now, I'm able to push to the trunk. Let me show you that change. I'll show you how it is configured right now and how it will be configured later. So if I try to make a change and publish it to the origin, I've shown you that it can publish to main, it can publish to any branch from here that is there. Now I'm going to protect it and enforce this policy where the mainline is locked and I allow changes only via pull request. I will also add a code review just to show you how you can add policies, like you can also integrate with continuous integration. That's what we're going to do in the next session. In the next mission, when we talk about continuous integration, we will also bring in the changes or feedback from there and have it part of the pull request model. All right. So let me demonstrate this. There's a question from Divya about monorepo, etc. I'll take that a little later. So how do we implement this is very straightforward. It's a very simple change to make to enforce trunk-based development. What I do is I go to my repository and add some configuration to the repository. Basically, I go to the settings, and this is where I see branches, and I have option to add a branch protection rule. That's what I'm adding here. To which branch? To the main branch. What rules? This is where I add the policy. I say require a pull request before merging. So the moment I add a rule, it is a protected branch. So you don't allow changes to it by default. The only changes which go in are via the pull request, right? This is already pull request. I can also say wait for the status checks, require status checks, but I'll have to select specific checks. I'll do that later. But pull request, I'm going to show you along with the code review. You can say this has to be approved by X number of reviewers. A good number is 2, but I'm just going to add 1 review here. So this adds a policy where it says any change which goes to the main line, any feature branch, we don't care, but mainline is protected. The changes have to be approved and reviewed by the peers. So this is where I add the code review. And I also say do not allow bypassing. Otherwise, I'm an admin, so I can bypass this rule. That's what it means by default. I say do not bypass. Now that I have this rule, what happens, I'll show you immediately, that if I try to make changes to the main line and commit, let's see what happens now. I'm on the main branch. I'm making a change, adding something to the README. See, there's a line added. shows as modified, committing the changes, still to the main line, but locally. And when I try to push the changes, it allows me local changes, of course, but because this policy has been added to GitHub, this is the time it says this is a protected branch. And it also requires reviews, code reviews. It says protected branch. So it declined that change. And it has to be also reviewed. So that's why this is declining me to, from making the changes, pushing this to the main line. So what I'll do is I'll undo the changes here. It's part of my commit history here, no? It's part of my commit history. I don't want that because I can't make changes and directly commit anyways. So I will this time reset the changes, but not only reset from the commit history, I'll do a hard reset, which will also remove it from my work area. I don't want these changes from in my work directory either, working area as well. But I'll create the changes again. So I have done a hard reset here, and then I'll create a new branch and check out to that. Get checkout -b does that, creates a new branch and switches to that already. And if I make the changes to this branch now, it will allow me. Again, I'm just done a similar change. It says modified, adds to the commit history, but commit history of the branch, not the main line. And then I push the change. Yeah, that's gone here. You can run a pull request from here. This is the branch where the changes have gone in. However, you will see now that if I try to bring the changes in, with pull request, shows me the diff also, right? So this is the line I've added. I'm raising a pull request. Earlier, it allowed me to merge. It just looked at merge conflicts and it didn't have any. But now it says merge blocked because I have enforced things here. So I can say, wait for the status, run a statistic and do that automatically with Jenkins. We will do that next week. But here I have added a simple policy saying that whatever code which goes to the main line has to be reviewed by at least one of your peers. One of the code reviewers have to look at that change. So whenever it goes here, this is where it is being reviewed at, and that's what is happening. So it's not allowing the changes directly to the main line. You can bring the changes to the feature branches, any branches, feature, bug fix, anything. But when it goes to this, it has to be, sort of controlled. And this is where I would add the reviewer. To add a reviewer, first I have to do something else, that is add a collaborator to my repository. So I have to give access to this repository to someone, invite him, and that's what I'm doing now. Since I don't have a teammate here to work with, I am going to add myself with a different account. So I have two different accounts. This is my regular account. This is the one I've created for demo. So if I go back to my reviewer account or my regular account, I should see I have a request. So this is my main account. And I have an invitation to join this repository as collaborator. I have accepted it. All right, now I have access to this. Now I see that pending invite will turn to this pending will be gone. So I'm a collaborator now. And if I go back, this is my demo account. This is where my repository is. This is where everything is happening. This is where I've made the changes at and raised a pull request from. And I go back to the pull request and add the reviewer. So this has to be reviewed by one. And I see now the collaborator. I've added the collaborator as the reviewer. If I go back to my reviewer account, I see the request for review. So this says there's a feature and a pull request, and I've been asked to review this basically. Can go to the, sorry, there's not this one actually. This is, I've done something wrong. What I've done wrong, no, this is fine. Been asked to review as well. Okay, to go to the right repository and look at the pull request here. I'm a reviewer. I'm logged in as reviewer here. This is where I can add the review from. It says I've been asked to review. I can look at the changes, look at the commits. There could be multiple changes, multiple commits as well, and I can review all of this here. And this is where I can review and say either I can add a comment and ask for the changes. Yeah, I can just add a comment, like discuss the code, add or ask for the changes, request changes, or I can go ahead and approve. I've approved the commit. The moment I approve, if I go back to this account, now it says it was blocked earlier. Now the changes have been approved, so it allows me to merge. I've added a status check box as well, but there is no status check set as of now. So that's why it skips that part. So it says continuous integration is not there. So there's nothing to do here. And this has been reviewed. So changes have been approved. Only the approved changes go into the main line. And that's what happens here now. And I will delete the feature branch as well. The changes are brought in, but they've been brought in safely. That is what this is about. The whole branching models and why do we implement it and how, that is how it is about. And that also answers the question about how do we maintain the developed branches, mainline branches. We protect those branches and we allow changes only via pull requests, and only merges are allowed, not direct check-ins. Can we run a CI test before merging? Yes, of course. That's what we want to add next. Next week's mission is about that. So we will add the CI test here as well. So that's another important thing we should do, because we want to make sure that our changes do not break the build. How do we automatically continuously test it? Is using the continuous integration platform like Jenkins, for example. And we will add that eventually. Next week's session, we will gonna integrate everything and add that part as well. So this week, we just wanted to set up the trunk-based development, look at this collaborative workflow. So we are setting up the foundation for continuous integration, continuous delivery, etc. So this is all part of that. And finally, I just want to show you how to, let's say I've made the changes and let's say I want to deploy this somewhere. So I'm ready to release. I want to create a release artifact or something like that. You might have seen releases for a lot of projects as well. How that happens is by tagging. How do you tag is by creating a release, by creating a version. How do you create a version is you should follow the semantic versioning scheme. What is semantic versioning scheme? It is a scheme with 3 numbers, major, minor, and patch, which is being used by a lot of products. Okay. And that's what I recommend you follow as well. So you may have seen even like you see Kubernetes releases, right? Kubernetes has released a new version. What does that mean? At some point of time, they decided that all the features are gone in for this particular plan, and we want to create a release. So you can see the releases being created. So there are like 614 releases. Are they all major releases? No, most of these are some beta or patches, right? So these are like patches. Mostly, there's a patch release. So 26, these are 26 version 27 version, which is being updated with bug fixes. So mostly if you look at this release and the change log, you are going to see the bug fixes, right? So that's what you will see in that particular change log and for a minor version, right? So you see minor versions, you mostly see, this was added or this bug fix is done mostly. So those are smaller changes called as patches, right? In this case, these are patches. And then anything which is a larger chunk of a change, but it is still backward compatible, you will release it as a minor version. So a bunch of changes, some functionality you add, right? And then that is a backward compatible. That is a minor change. And then there is a major release. But this is easy because when you say, when I update, that's why I would feel comfortable upgrading from 1.26.6 to 1.26.7, right? Because there I know it is backward compatible. So if something goes wrong, I can always go back to previous release without any headaches, basically, or without anything breaking for me. So this is backward compatible versus when there is a major release from version 1 to version 2, there you have to be very, very careful, really, right? Um, and that's like a major release that goes out. So that is the semantic versioning. So there is a major version where you make incompatible API changes, minor, where you add a functionality, but with backward compatibility. And the patch version is like typically bug fixes, but it can also be certain features which are getting there, but they're not being activated. So that's the semantic versioning. So when you see a version like this, that's what it means, major, minor, and the patch version. How do you create these tags is very straightforward. So git tags, I see nothing right now because I have not tagged anything. I have not published anything. I have not cut any release, right? So if I want to do so, how would I do that? There are a couple of ways of doing it. I'm going to show that. I can also create a release branch. Let's say I've done this and I'm ready to release. So I'll create a release branch at this point of time. And the reason I would want to create a release branch like this is because this is what is being tracked by a particular production environment. So when I deploy, I will deploy from this branch. And then anything which, let's say I have some bug fixes, there is a bug and I fixed it. So there is gone into mainline, but that is also cherry picked, as in that one commit is taken and updated to the release branch as well. Because for that release, till the next release, whatever changes are going or any bug fixes, hot fixes are going, I can maintain it in that release branch. So I can also do that. And then I can cut a release from it, as in I can tag. So when I say I cut a release, I'm tagging. So there are a couple of ways of tagging. One is an annotated tag like this, where I'm defining the version. So in this case, this is a minor version. You may have guessed it already. And I'm adding an annotation saying, this is what I'm doing with this release. You can also tag it like this, just without any annotation, like this is without -a and the message, just a version. Both work. However, I'll show you the difference. So when I say git show, shows me the last, this one, 4.0. The difference between 4.0, beyond that versioning scheme, major, minor, don't worry about that. The real difference is annotation. This just has the history of commits when it was released. In addition to that, this has an annotation. So if I want to add anything related to the information about why I released at what point of time, what went into it, a change log or anything, I can add it here as an annotation. So that's what annotation is about. And annotations are good to have. And at end of it, if I want to publish these or just one of this, I can do so as well. I can also delete the tag using git tag minus d option. So I delete one of this, git tag minus d 4.0. this is how I push this to the origin, as in the GitHub repository. This is how I do so. And at this time, I should see the release been added here. There were no releases. Now, if I refresh, there is one. This is how you see the tag. This is how you see the releases. And this is where you can add the annotation. This is where you can add the change log and a lot of other things. So this is the release. So you see, all of this was annotation. So you add the annotation, you add more information about it, and all the stuff here, right? And what is part of the assets. You can define all such things with the release of your product, basically. Anyways, it is available at that snapshot at that point of time with this covered. If I just download the zip file, that would be my like an kind of an artifact as well that I could use to deploy to a particular branch or whatever. That's what I call as a release, basically. And this is the kind of workflow that you can set up with Git and GitHub. We already have talked about a bunch of things, which include, let me fold everything else. Right, so we talked about the basics of Git workflow: add, diff, commit, push, fork, pull, clone, all of that. Branching and merging, very important topic. We talked about the pull request, again, extension of the merging, but it allows you to add processes, add compliances, checks, code reviews, status checks from CI, etc. Branching models, which help you implement the workflow. That's how you define like, oh, how many branches I'm going to keep, which branch I'm going to release from. Do I create a different branch for staging? Do I create a different branch for development? What do you do, and how complex my system is, and my deployment workflow is. So all of that would revolve around this. So this is important to understand and to get started with. And there are a few additional things that you may know about, like how do you undo, like reset versus rebase and those kind of things. But apart from that, if you go through this content, you will have the basics of Git and working with GitHub all sort of covered. And when you start working with GitHub, you can also switch to GitLab or GitStash or any other system, which is a hosted system with Git, right? So you can just start working with that also. It is going to be the similar thing. There will be, of course, different slight differences between different platforms, but not too drastically different, basically. Right, so that's what this is about. I think there's a question outstanding from Divya about mono repository versus poly repository. Now, this is kind of depending on how your workflow is, right? So what is a mono repository? What is a poly repository? I'll give you some examples. Okay, we already have something here. So when we talk about this application that we're working on.
So, hi Gaurav.
Yes, Divya.
So I asked this question in the context is that sometimes when we start a new project, like especially if it's a greenfield project, then
Mhm.
like this question comes up, right? Whether we put all our microservice code or the application code with the infrastructure code in a single repo, or are going to split the repository like a poly repo, service based each repository, and like sometimes like what are the advantages, or is there any kind of framework or checklist that we should look into that we can go for one repo over the other, like
Mhm.
considering the CI will be the input for all the repos, right? So
Yeah.
sometimes it's like when we are having a mono repo, the CI need to be defined in a different way compared to the CI when we have a poly repo.
Right. Okay, so before I answer that question, because a lot of people here are new to Git, I'm just going to talk about what is a poly versus a monorepo. And I understand your question is more from, not from application, multiple application, but from the point of view that where do you keep the application code versus deployment code? right? Should it be
Yeah,
part of
yeah.
the same or should it be part of a different repo? I'll come to that. But let me just talk very briefly about what is a poly repo, what is a mono repo, what are we talking about? Let's say I have an application where are three services, front end, catalog, and cards. In this case, how many repositories do you see, right? You see many, but for front end, there is one. For cards, there is one. For catalog, there is one. Maybe there are different teams who are working on each of this application and they're maintaining this repository completely on their own. And there's a completely different repository altogether, right? This is a concept of mono repository. Mono is one, poly is multi. Sorry, this is a concept of poly repository. Sorry. Uh, you can call it as whatever, right? So poly, it's not a mono, it's a multi-repository, it's a poly repository. Let's call it as poly repo. Now, what is a mono repo? An example of that was somewhere we saw the application Instavote, right? Or let me show you that. In this case, what happens is there are three services, but there's only one repository. It's just one repository, but application for vote worker result. Again, three different applications. This is a Python application front end. This is a backend Java application. This is another front end used by something else, which is a Node.js application. Part of the same application here, vote worker result, but everything is maintained in one single repository. This is called as a mono repository. Now, for the question is more from not like multiple microservices. The question is from, oh, I have the microservices and I'm maintaining a repository for it. And there is a deployment code also. So where do you keep that deployment code? Let's say Kubernetes deployment code. My suggestion is you keep the deployment code in a separate repository. When we especially start scaling out, that becomes very helpful because a lot of times you may want different access control. You don't want developers to work on deployment. You don't want everyone to have access to your production deployment code. If the production deployment code and staging and everything is in the same repository as your application code, all of that can create challenges. And I would suggest you create different repository for your different for deployment for that, right? And in fact, there is no like structure or framework, but I have created something in my GitOps course. So if you have access to that, the GitOps course is let me quickly show you which one.
So
The
one
Flux
query.
course. There is a multi-tenancy, and there I have this framework where I split the code, and there are three repositories I talk about. One is the application, second is deployment, and then third is a infra repository for the actual cluster deployment.
So what happens is that sometimes requirement comes is like when we are working on a project, the requirement comes is like, the developer wants a preview environment for them when they create a feature branch out of it. So I know that that's more aligned to mono repos because you have the code base and you have the infrastructure code with it or the deployment code with it. So when you create a feature branch out of it, you can add the DNS on top of it and create a preview environment, and we need to delete that when it get to the merge. But can it be created through poly repos or multi repos?
So what you'll have to do is you'll have to maintain the a tenant. So you create a tenant repository. So you can have your application code. You can have a tenant repository where the deployment code is, and then an infrastructure repository where your cluster configuration and all that. So you can have that kind of a structure. Or in this case, if it is a very simple scale, if it is a smaller scale, you can also club the application with maybe their preview environments and that deployment code. And that way they can have access to the code as well if they have a control over. So who controls the code? It all depends on that. So you can design it however you want it, and you can have a separate repository where the production deployments and infrastructure setup and everything else is being deployed from.
Yeah, did you have any kind of example or any kind of block page to look for the tenant one?
Yes. So there is a multi-tenancy. I'll tell you where it is. If you go to the course on GitOps, I'll tell you which section to look at. And this is a very specific. I spent a lot of time just to design that, and it was based on certain other references. So you look at I'll tell you which course. LFS 269, GitOps with
Okay.
Fluxcd. And I'll tell you which chapter it is. So it is basically, it comes much later. This is related to multi-tenancy. So yeah, multi-tenant design. This is a multi-tenancy chapter there. And there it is explained actually. I have some illustrations for that as well. So you have application code. So I initially started with this, the application code and deployment code. And then I ended up creating multi-tenancy where this is my tenant. Tenant is nothing but all the deployment code related to that app is now part of the tenant repository. And then I have a fleet is more like infrastructure, because at the cluster level, you are also deploying ingress, you are deploying some RBAC policies. So no developers anyways need an access to all of that. So that goes in this infra repository or fleet. Let's call it as infra. This is the tenant repository where all the deployment code for this application resides and the actual application code. So you can create this design. This is a slightly complex, but very flexible and scalable. Or you can start with, let's say, like this application code and have an infra repository and then give developers access to this as well. So, it really depends on that. Who needs access to what and how you're going to develop and who's going to create the deployment code and so on and so forth. So all these questions, answer to that will lead you to your design basically.
Okay. Yeah, I'll have a look.
Yeah.
So just one follow-up question is the app repository is being pulled as a submodule in the tenant repository or
No. There's no submodeling here. I don't like submodeling because it makes a lot of things complex. So this
yeah,
is
yeah.
not submodeling, but in this case, this is a tool called as Flux. So Flux is what we are using to deploy everything, like right from RBAC policies to infrastructure components and nginx. And this is where I onboard the tenant from. So this is where I say that look at this repository. So it is referencing this repository. So when I
Okay.
onboard an application, it will automatically pull the code from here and deploy. And then that is when I have this setup basically. And that is how it basically happens. So this is a reference. So when I onboard a project, this is referencing to this repository. And in case of Flex, that's what you do. You say that this is my repository and find the code here and deploy and all that. So it goes here and deploys basically.
So it
The particular
monitors
cluster.
the tenant repository
Correct,
continuously.
correct.
Like if I create a
Yes,
new
yes,
tenant,
yes.
it
So
goes and
there
deploys.
are, in case of Flux, there are resources which monitor one specific repository. So you create that for every repository. There is a resource which is monitoring for changes. If it detects the changes, it will say, go and trigger the deployment.
Okay.
Yeah, that's what happens here.
Thank you.
All right, cool. Okay, any other questions, folks, to get started with? Okay, so by the way, if you want to get started with the membership programs, and we are restructuring everything. So our current silver membership for existing members also, we are calling it as it's going to be silver, but the program name is going to be called as a DevOps Associate Mini Degree. And you are already part of that if you're a silver member. And the gold membership, which gives access to all the courses, which is more like a self-mastery pack, which is this. You can upgrade to that as well. And for those of you who want to join in, and if you're part of the Zoom session, I'm just sharing a link with you, which you can use to sign up using a sort of a webinar special access coupon, right? So that is being shared in the link here. And I'm going to post that link to YouTube till tomorrow. and it will be available for a limited time. So if you want to sign up till tomorrow, you could do that as well. So if you are on the stream on, let's say, Facebook, YouTube, or LinkedIn, I would be sharing the same links with you if you want to sign up to these programs. And with that, we will conclude the sessions here. And what I would suggest before we sign off is basically, this is where you will find everything. You go and look at the DevOps Hackathon roadmap, and you already have access to this from the main section anyways, but this is a more elaborate one. And this is where you'll find the details of the steps which are required to be completed. You also have the progress bar for the steps. And once you complete these steps, you would be assigned the Gitofy badge as well. So for every single milestone, so we're converting into milestones. So there are 11 milestones for 11 missions, and every single milestone will lead to a badge. So you can accumulate the badges, and you will actually see people being allocated those badges. So if you see here, right, so people have completed the milestone, and let's say Gautam has completed the mission 3, and you see that milestone is being added to the profile. So if I go to Gautam's profile, I'm going to see the badges here, all the badges which are earned. And that's part of our gamification. So all the badges, all the certification, how much time you spent learning, how much time you spent working on the project. So every time you complete a mission, you're also allocated the project minutes. So you were awarded those many project minutes. This is roughly based on how much time you'll be spending on the project for a particular week and a particular, let's say, the nano project. So there's a learning time, there's a project time, and all of that gets accumulated to your profile. And based on that, it is going to lead to the certification and the mini degree program. So when you actually complete the mini degree, you have a proof that you have completed this much of project work, this much of learning work, and that gets reflected onto your profile as well, right? So that's it for this week. Let's start Gitofying, and let's come back next week when we are talking about pipelinating. This is where we're going to build the continuous integration platforms, and it's just going to get even more interesting from here on. I can promise you that. So thank you very much. Let's keep up with the pace of the hackathon again. And people who have not joined, you should definitely be part of this week's, this quarter's hackathon. And we do this hackathon every quarter. So even if you miss some part of it, you can always catch up later. And this is based on how much work you do. Based on that, you'll automatically get awarded with the certification and the badges and the degree, mini degree, etc. That's it for this week, folks. Thank you. And I'm going to see you on Thursday with our inner circle call, and next Tuesday with the next mission, where we'll be talking about pipelinating, that is building the continuous integration pipelines. That's it for today. Thank you. Bye-bye.